Hello there, my name's David Knight. I'm the author of this website. My project for my computing and IT degree is based upon my main job. I'm a community optometrist. I also work in hospital, and I work with a lot of people who are living with cognitive impairment, and I see on a daily basis the problems that can happen if your vision deteriorates. And a lot of people I see unfortunately have falls and are unable to enjoy the things they still would like to do. It includes watching the television and reading, and even playing dominoes or these sorts of daily activities, being able to see the food on your plate and things like that. So it really does matter if somebody's eyes begin to fail, and if they can't tell you that's what's happening, then it's not always obvious. So when I go into a care home and look at people's eyes, sometimes I'm quite surprised that someone's vision is very poor, and if it can be picked up before I go in, I would much rather that was done. So the idea was to create an assessment tool that can be used in theory by anybody, but in particular for people who work in care homes, so that they can use pretty much bog standard commodity hardware and do an assessment on somebody's eyes without having to rely on that resident to tell you what they can see. So instead of using a standard eye test chart, as you might see when you go to the opticians and read the letters from the chart, this can be done automatically without the person doing the assessment saying or doing anything in particular, and without the participant having to tell anybody what they're seeing. And this is done using a webcam based tool, which can analyze the image that it receives, and using a number of other libraries, most of which are open source, it can then work out what the participant is looking at, and then present the participant with a number of different stimuli, visual stimuli, which it can then work out whether the participant is looking at them or not. So that's a bit of background. So I'm going to talk you through exactly what's involved and how we do it. Before that, I'm just going to show you a few features of the website. So what we've got here is a little bit of go through the footer, contents, and a little bit more about me, and what I do and what I'm involved in as well. There's plenty of other information on here to have a read through in your own time, of course, as well. Then we've got information about the resources that I've used, which do not belong to me, or pretty much all of which are open source. There are some images, some placeholder images, which I've also used on the main homepage of the website. I expect they're going to be replaced fairly soon with some of my own content, but at the moment I'm just using those to make the website look a little bit more attractive at the moment. Then we have some contact details as well. I have got my own sort of email address relating to the project at the moment, which I'm showing there at the moment. I've also got a Twitter handle there as well, which is sort of my primary social media space as well. A privacy policy, which tells you all about what we use the data for, and also contains information about I've used the Open University's Data Protection Officer details there, as it's an Open University project. But again, there's information about the kind of security that I'm using. I'm using AES Security Advanced Encryption Standard, and the key length is 512 bits. And I did work out that the number of possible combinations is in the region of well over 1 Googleplex, which is a phenomenally large number, and I don't think anyone's going to break into that at any time soon. And also, again, we're following the Data Protection Act, of course, as well. Then we've also got the terms of service, which again are fairly straightforward at the moment, and again pretty basic at the moment. But again, just to confirm that you use the website at your own risk, essentially. And also on the footer, you'll see a little copyright message there as well. So back to the home page then, and you'll see there are 3 buttons on the home page. So you've got the assessment that you can begin if you wish. You've also got 2 other options down here, which are to remove any personal data that's stored, or to remove any calibration data. So the data is stored in on the particular system that you're using. Information is taken off the server, but nothing goes back to the server, so no information will be transmitted from the local machine that you're using. So we're going to go ahead and remove the data on the system. So I'm going to remove the calibration data and also any personal data. So now at this point in time there is no data on the system so we're going to have to replace it. So we're going to start the assessment. And the first screen, of course, it's going to ask you which webcam you want to use. On this particular laptop that I'm using, there is only one system. There's this HD camera, so we're going to click on that, and there I am. So that's the camera that I'm going to use for this assessment. Just whilst you can see, I'm going to show you some of the extra tools you need in order to get this prototype to work. First of all, you're going to need some kind of tape measure. So I've got a normal tape measure here. You're also going to need a credit card sized object, so I've got my little membership card here, which I'm going to be using shortly. And finally, you need a chessboard, which I've got here. Again, a normal, quite an old chessboard, that one, which is quite important because again, the whole point of this is these are things that are commonly available in care homes. Pretty much every care home will have access to a chessboard. Again, tape measures and so on, these are commonly available tools that will be around in the environment that's intended to work. So we're going to select the webcam, and then it's going to take me straight onto the webcam calibration page. So webcam calibration phase is really important because what we're trying to work out is we're trying to map the image that we're seeing on the webcam to a real life measurement. So we want to know exactly how large the objects are that the webcam can visualize. So to do that, we use an object of known size, and that object is the chessboard. So we're going to document the square width and the square height. Some target test patterns don't actually have equal width and height. So for some patterns, it is important to put a separate width and height in. But on a chessboard, you're looking at squares, and therefore they're going to be the same. This particular chessboard has a width of 30 millimeters, so we're going to put that in there. If I make a mistake and I accidentally put 300 in, let's see what happens. Begin the calibration, and it straight away tells me that the square size is too big. Of course, it's quite right, so we're going to change that to 30. And indeed, there are plenty of checks like that as we go through, and we'll encounter a few of them as we go along. So we're going to begin the calibration now, and again, it's going to come back to an image of me, and it's going to ask me to hold the chessboard up in front of the screen and move it around. So that's what I'm going to do. So that's my chessboard, and that's lovely. So nothing much is happening at the moment, but you can now see some lines have appeared on the chessboard. As I move it around, you'll see they appear more and more. So what's happening now is that the system is looking at the input image and trying to find the square patterns, and as it does so, it maps the corners of each square where the squares meet, and it works out the coordinates of each of these patterns. And then once it's done that, it stores the images, and when it's stored 30 of these images, it will then start to analyze the images. So we are almost there now. There we go. So now it's processing. Of course, this will depend on how long it takes to process, will depend on on the speed of the computer. This is all being done on the actual computer that you're using. Nothing is being sent to the server. So it's done that, and it's obviously passed. If it hadn't, it would have brought up an error message telling me that that the calibration was inaccurate, but obviously I was happy with that calibration. So we're going to move on to the screen calibration. So now we know about the camera, the details of the camera. What we don't know is the details about the screen. Now the computer can find out the number of pixels, the height and width of the screen in pixels, but it needs to know the physical screen size. And so that's what this is all about. So this is what we need the tape measure. So it's asking me to measure the diagonal screen size. So I'm just going to do that. And that's coming out at a measurement of 36 centimeters. So I'm just going to enter that into the box here. And we can change that to inches if we want, but I'm going to keep it at centimeters. And then it's asking me to change the shape of this image here to match the shape of the credit card. So again, I've got my little membership card here. Again, credit card size objects are pretty much ubiquitous nowadays in modern society, so pretty much everyone will have one. So I'm going to set that now to the same size width there. There we go. That's about right. I'm going to complete that calibration. Now what it's telling me is that the two values are different, and the reason they're different in this case is because the screen is actually blown up. So I'm going to reduce the screen size now to the normal 100% level. I'm going to do that again. And now hopefully it will, yeah, that's great. So we're now calibrated. So now we have the screen calibrated and the webcam calibrated. Now, although I can continue at this point, I'm going to just reload because I want to show you that that process only needs to be done once. So now we go back to the main screen again. Calibration data down here is now saved, and I can now begin an assessment, and it takes me straight back to the previous screen because all the previous steps have been completed. The next screen we're looking at now is for the consent. So this is where the participant needs to provide consent, and this is essentially a legal requirement because we're going to be obtaining information digitally from the participant. We're going to be measuring their vision. That's health data, and that's protected characteristics. So we need to make sure that before we do anything, that participant has provided consent that we are allowed to do that, and therefore they're going to fill out the details. The assessor needs also to fill out their details so we know who took the consent. So we're going to call them Mr. Assessor, and they have to consent, so they have to tick that I consent box, and then the participant fills in their details, and then we're going to call them Mr. Participant, and then they're going to sign the form, and we're going to sign. There we go, that'll do. So now the submit button becomes active, so we now can submit. And the next option we've got is whether we want to save or whether we want to print. So the reason this option comes up, of course, is it's critical that we have proof that consent was provided, and therefore we either save it onto the local system or we can print it out. In this case, I'm going to click on print, and as you can see there, notice the boxes are now missing. We've taken those off because they're not really important for the form, but the contents there, the signature box is there, and we can save that as a PDF. In this case, I'm going to do that. I'm just going to put it on my system and save it as a PDF. Save. There we go. And now the assessment starts, and then the first thing you'll notice is a great big black spot in the middle of the screen, which of course your eyes are naturally drawn towards. In a moment, a video screen will appear in the corner of the screen, the top left-hand corner, and you'll be able to see me again. And this is important for the assessor to make sure that the eyes are lined up in the center of the screen. If they're not, the computer will tell you. It's still loading. The border is currently black, and now what's happening is the application is monitoring my eye movements as I follow the black dot around the screen. As it's doing so, it's collecting important information about my gaze position, and it's using that to make predictions. And as it does so, it works out the accuracy of each sector. So on the screen there are 9 sectors, a 3x3 matrix, and for each sector I have to score a minimum accuracy level in order to proceed to the actual assessment. So as the dot moves around the screen, it's defining the border of the screen, of course, by moving around the edge, and then it moves into the center of the screen. So now it's got an idea of the accuracy for all areas of the screen, and what's happening now is refining that accuracy. Again, as I look towards or away in that case, so I'm not actually looking quite at the black spot turns red. And of course that's a much more eye-catching colour, so I'm more likely to look at it. You'll also notice that when I'm not looking at it, that spot becomes bigger as well. Again, the spot moves around the screen. What's happening is, again, each area it's looking at is checking the calibration levels, and it's working out whether or not I'm looking at that part of the screen or not. If I'm not, again, it turns bright red. You'll notice when it suddenly jumps that often I'm not looking at it, which of course is logical, and then I look at it. You also notice briefly there that if I don't look at the screen, then it flashes up a warning message and pauses the test as well. So for example, if I look away now, it will come with a message saying that I'm looking away, and then I look back at the screen again, and the test will continue. As I look at the red dot there, because of course I've just confused it, now it's looking at all the different areas and making sure that they're all calibrated. And indeed, if somebody has a cognitive impairment, it's very likely that they will not look at the screen constantly. They will look away from time to time. And indeed, so it's very important that the assessor knows that, whether the participant is looking at the screen or not. And those warning messages are again there for the assessor to be aware of. So the calibration process is continuing. The calibration process will take varying amounts of time. If I'm a very good candidate, which by the way I'm not, because I'm looking away from the screen and I'm misbehaving a little bit, then it can be done within about a minute. In my case, probably be another 30 seconds or so, I would guess. You'll soon know when the calibration is completed, because a series of dots will appear on the screen, and that's really there so we can sort of assess how accurate the calibration is. Oh, there it is now. So I'm controlling the little red dot. I'm looking at the top left dot there, looking at the center dot now, and moving on to the assessment now. So this is the actual assessment, and what you'll see is a series of gratings, black and white gratings, appearing on the screen. The eye is naturally drawn towards the gratings, and as you look at them, you'll notice they start to get smaller, and the reason for that, of course, is because I'm looking at the gratings. So the number of black bars will increase gradually over time. If you look at the top left-hand corner of the screen, you'll also notice that it's measuring how far away I am from the screen as well. That distance relates to the distance from the webcam to my eyes. And again, if I move backwards a little bit, you'll see that the number increases. And then I move forwards again, and the number goes down. So again, still looking at the black lines there. And you'll notice also that the vision measurement will change a little bit as well when I move further away, because the lines are staying the same size. You need better vision to see that from a further distance. And so therefore the measurement, the estimation of acuity also changes as well. Again here, I'm not being particularly very good at this test at the moment, unfortunately, because I'm too busy concentrating on what I'm saying as well as what I'm doing with my eyes at the moment. But you'll notice the bars are still getting narrower slowly. There is a limit currently of 30 presentations. That is completely arbitrary. I can change that to whatever number I want to, of course. But in future prototypes, of course, it will be adaptive, so the number of presentations will vary depending on how good or misbehaving the candidate is who's doing the test. But at the end of that, of course, we should end up with a report, which will come on the screen very shortly and will tell you how good or bad I am. I have a feeling I'm going to fail the test because I'm not really paying attention, but we'll soon find out. You'll notice that I haven't touched or moved the mouse in any way during this assessment. I don't need to. This has all been done controlled using the webcam. The webcam has now turned off, and it's presented me with a report screen, and the report contains various details about the kind of environment I've done the test in. As you can see, that I've been working at working distance of 43 centimeters on average. The screen properties had a pixel density of 62 pixels. Certainly in the tests I've been doing, The main limitation in terms of accuracy is the actual screen resolution. I don't have access to a retina display screen. This is a pretty standard, fairly modern laptop, few years old, and I believe it's 155 dots per inch and number of pixels per inch. So that's the kind of level of detail I'm able to see on this screen. And even as you say, that the best vision achievable on this screen is 0.41 logmar. To give you an idea, 20/20 vision is 0 logmar. So 0.4 is significantly larger detail than 20/20 vision. So with this particular device, it's impossible to estimate whether I can see 20/20 unless I'm sitting a lot further away. So perhaps if I was a meter away from the screen, I might achieve 20/20 vision on this screen. And certainly when I've been experimenting on it, you have to be around about a meter away to get that level with this screen. With screens with much higher density of pixels, and that includes things like modern tablet displays, for example, then you can get much higher resolution. And with those screens, it's totally feasible that you could get 20/20 vision on those screens quite comfortably with again fairly standard tablet without spending too much money. It comes up with a recommendation, as you can see there. The recommendation is that I failed the screening and I should have my eyes tested. And of course, it's done that because the current algorithm for the assessment needs to be improved, because clearly the end point is fairly arbitrary and needs to be a lot more well defined than it is at the moment. In addition, future prototypes will take on board the accuracy of the calibration assessment. So if the calibration took a long time and wasn't particularly straightforward, the assumption is that the assessment will also be likewise more challenging and more difficult as well. So this is the second prototype demonstration. We're now moving on to our third prototype, and we'll be back to demonstrate that when it's all finished. Thank you for your time.